Welcome to Effective Teaching and Learning for Secondary Science. This is Module 5.3. Let's start our discussion on inquiry-based learning with an examination of a scenario. In this scenario, several teachers are discussing their understanding of inquiry-based instruction. The first teacher says, "For my students to be involved in inquiry-based instruction, they must develop their own questions to investigate." The second teacher says, "Inquiry-based instruction is the only way we should teach science in middle school." The third teacher claims, "Since my class is often doing hands-on activities, I'm using inquiry-based teaching methods." And the fourth teacher states, "When I use inquiry-based instructional methods, the order of the lessons in the unit doesn't matter much." With which of these teachers do you most agree and why? With which of these teachers do you most disagree and why? Let's continue our examination of inquiry-based instruction. So what is inquiry-based instruction, and why is it so important? According to the National Science Teachers Association Standards for Science Teacher Preparation, Standard 3, teachers of science engage students in both studies of various methods of scientific inquiry and in active learning through scientific inquiry. They encourage students, individually and collaboratively, to observe, ask questions, design inquiries, and collect and interpret data in order to develop concepts and relationships from empirical experience. Thus, utilizing inquiry-based instruction provides students with opportunities to both ask and answer or solve questions and problems. And while different levels of teacher scaffolding can and should occur throughout the process of inquiry-based instruction, it is an instructional model that taps into students' curiosity and quest to examine new ideas and perspectives. With these things in mind, the National Research Council suggests that teachers do the following in order to guide and facilitate learning through the use of inquiry: focus and support inquiries while interacting with students, orchestrate discourse among students about scientific ideas, challenge students to accept and share responsibility for their own learning, recognize and respond to student diversity and encourage all students to participate fully in science learning, and encourage and model the skills of scientific inquiry, as well as the curiosity, openness to new ideas and data, and skepticism that characterize science. Thus, inquiry-based instruction is strongly recommended as an effective technique in the K-12 science classroom. But should inquiry-based instruction be used 100% of the time? The answer to that question is no. As Content et al. Support, a myth emerged that all science lessons should be inquiry-based. This was never the intention of the National Science Education Standards. The emphasis on inquiry was not meant to recommend that a single approach to science teaching be used to develop knowledge, understanding, and abilities described in the NSES content standards. Thus, inquiry-based instruction is just one way out of many to teach science effectively. With that in mind, it is important to understand that a range of levels of inquiry, as well as scaffolding, encompass the instructional model of inquiry-based instruction. Thus, the instructional model of inquiry-based instruction falls along a continuum of science instruction emphases. As you can see here, inquiry-based learning can range from the high extreme of being open to students, thus resulting in what is known as discovery learning, or can range towards guided inquiry that is more scaffolded and supported by the teacher, all the way to what is considered expository teaching, which involves little to no inquiry, thus known as reception learning. The focus in science education reform today, and what much research supports is most effective for students' knowledge construction and long-term memory retention, falls somewhere in the middle to high range, thus erring towards inquiry. So, to clarify, inquiry is just one of many varied instructional strategies that should be used when teaching science. Learners need not generate and pursue their own questions in order to be involved in true inquiry. Teaching through inquiry requires a skilled teacher aware of the nature of inquiry-based instruction. Even the use of the best instructional materials does not ensure effective learning. Inquiry-based teaching and learning requires more than student involvement in hands-on activities. And inquiry-based instruction must occur in the context of science content. You might wonder then, what are the benefits of inquiry-based instruction? Well, research supports that inquiry-based instruction facilitates the active development of understanding, increased student engagement, increased reasoning and thinking skills, and importantly, mimics the methods that are used by scientists in the real world. This is because inquiry allows students to interact with objects and events, ask questions, construct explanations based on evidence, test explanations, and communicate ideas. Furthermore, research supports that inquiry-based instruction supports problem solving, encourages creativity, fosters independent learning, improves observational skills, and improves logical analysis. And, as Content et al. States, research also shows that students exposed to inquiry methods in science typically perform better than their peers in more traditional classes on measures of general science achievement, process skills, analytical skills, and related skills such as language arts and mathematics. And likewise, studies consistently found that when compared with students in more traditional, textbook-oriented science programs, students engaged in inquiry activities found science more exciting and interesting, had greater feelings of success, and had a more positive view of science and scientists. And interestingly, these benefits extend to special populations, such as English language learners as well. There are a few things to remember though. Not all inquiry looks alike. Remember that inquiry occurs as a range along a continuum. Likewise, inquiry does not have to be continuous, nor does inquiry have to be limited to one class period. In many cases, inquiry might extend among several days or even weeks. Importantly, hands-on activities do not always equate to inquiry instruction, and the teacher role shifts when inquiry-based instruction is used. When considering the teacher's shifted role, the teacher should serve as a facilitator or guide during inquiry-based instruction. As Content et al. Remind us, the teacher's role in an inquiry-based learning environment is less involved with direct teaching and more involved with modeling, guiding, facilitating, and continually assessing student work. Likewise, it is important to remember that pedagogical content knowledge is essential to the process of utilizing inquiry-based instruction. Thus, the teacher truly must be an expert within his or her subject area in order to effectively implement this type of instructional model. However, it is okay for teachers to answer student questions with, "I don't know. How can we find that out?" as it is impossible to anticipate the types of questions that might arise in an inquiry-based setting. Finally, what does inquiry instruction actually look like? Well, the National Research Council suggests the following essential features of classroom inquiry. When each of these elements occurs, even if not simultaneously, inquiry is occurring. The features include: learners engage in scientifically oriented questions. Learners give priority to evidence, which allows them to develop and evaluate explanations that address scientifically oriented questions. Learners formulate explanations from evidence to address scientifically oriented questions. Learners evaluate their explanations in light of alternative explanations, particularly those reflecting science understanding. And learners communicate and justify their proposed explanations.